This meeting is being recorded.
All right. Welcome everybody to our Cloud Native Toolkit office hours. Today we're going to talk about iteration zero, the iteration zero tools, how to customize them, how to run them, a little bit how to deal with issues that when things don't go as planned, and then just kind of go from there. So we talked about Terraform in more detail a couple of weeks ago. That video is available for viewing. We'll make sure the links go out to everybody. So we're not going to do kind of an abstract talk about Terraform, but we're going to talk more specifically about iteration zero and how we're using it, how you can use it on your projects. So let me share my screen. I'm not used to use this way, but hopefully the contrast is easier to see. This was like this. We did another recording earlier. So iteration zero, there's a couple parts to it, and I'll kind of walk through. First off, I guess everything I'm going to go through is described in the administrator guide on some level, for how to set up, how to customize, and all that. Infrastructure as code is where a lot of the customization discussion happens. But that said, I think there's an opportunity for making that documentation clearer. So if any questions, or as you read through it and you see gaps or issues, please submit pull requests, or at least issues, so we know about them. So the starting point here is providing your credentials. When you first clone this repository, you get a credentials.template. It has these 3 empty values in it. One of the things we're going to be doing is renaming these to be, at least this one, to be more appropriate across all the environments. So when you're on IBM Cloud and provisioning and deploying in, this needs to be your API key on IBM Cloud. And I'll go back and show in just a minute how to get that. If you're provisioning into an existing OpenShift cluster that's on AWS or somewhere else, this would be the password of your admin user. So that key name really doesn't make sense, but it hasn't changed since we first started, where it was just IBM Cloud. So that's the first thing you need to provide. Now, there's been some confusion on where you get that value. So your API key is accessed here through this access IAM, and your API keys. Now, a couple of things. The API key is specific to account. So if you're switching between accounts, I'm in an account we use for some of the activation and training. If I create a key here, it is specific to this account. If I go to another account, then I will have a different set of keys so I've only got one in this account that I would use to access anything in this environment. So the key is not attached to your user ID. It's your user ID plus your account. So bear that in mind when you're looking at it. I've found, in most cases, maybe you're only going to be in one account. But if you're switching between accounts, I store them in one password and use them, access them that way, or a password management. Because once you've created it, like most things, you cannot see it again. So that's where you get your API key. You would put that in here, right? You need to make a copy, credentials.properties, and set the value. The reason we do that is credentials.properties is in our git ignore. We don't want you committing your credentials into git. So the template is persisted, but the properties are not. So that's the first thing, set up your properties. And then the next thing we need to do is describe the environment. Now, So correct me if I'm wrong, Bobby. The tests that you guys ran, the classic infrastructure keys weren't required explicitly, or are they still required?
Yeah, it looks like those aren't needed, so we'll probably take those out.
Okay. So these, in the past, it looks like they've incorporated all that into your one API key. It carries your classic credential. So you need to have, if you are going to provision the cluster as a part of running the scripts, there's two main models. You can either have an existing cluster, however it got there, it's there. And you want to install the tools and maybe provision services and whatever else on top of that, then you don't need any classic infrastructure. But if you're going to provision the cluster as a part of running the script, then you need to have classic infrastructure permissions to be able to do that. And previously you had to actually register the keys in. It seems like that's not needed anymore with some recent changes. So when I go configure a cluster, there's a couple things that we need or we expect. So the first is a resource group. You get a resource group, and if Bobby did an excellent job last week talking about how the hierarchy of the account is structured and how access control fits in with that. The resource group is one of the key components of segregating different work within the account. You get the default resource group called default when you first get the account. We highly, strongly recommend not using that, but creating a resource group. It's easy enough to create a resource group in the account resource group, and you just say create. Still, I'm in the wrong one. So you say create, and you can create a new resource group and use that to segregate the work that's been created. So that's the first thing: is you set the resource group that's already been created. We expect it already has been created that we're going to be working in. We have this name prefix and cluster name. They kind of work together. The idea is if you are creating a cluster and you don't want to mess with anything, you can set a name prefix. That gets added to everything that gets created. So if you're provisioning a cluster and you have a name prefix, it would be, in this case, GCT showcase OCP4- cluster. If you wanted to name your cluster something else, you can provide that name. If you don't provide either of these, then it's going to name everything based on your resource group. So in most cases, that's probably okay. So it would be GCT showcase cluster, and if I provision logDNA and sysdig, it's GCT showcase -logDNA, GCT showcase -sysdig. So if you just have one cluster and all the services are related to that cluster, then that's probably okay. Oftentimes, the way we're deploying now is we'll have, especially for our own testing, an IKS, an OCP3, and an OCP4 cluster all in the same resource group. So that's why the naming is like this. So there's a set of resources that are specific to the OCP4 cluster. And then, well, you need a region. The VLAN part is historical, but you need to specify which region you're deploying into. So we support all of the regions that IBM Cloud has. So US East is Washington, DC. US South is Dallas, and on and on. So that you can specify which region you want to deploy into. So, and it will, any services that get provisioned along with the cluster will be in that same region. So that's what that value is used for. And then we need to say what type of cluster we're using. We support 4 different options here now. Kubernetes, OpenShift, which is essentially OpenShift 3.11, OCP4, so that's 4.3 really, and then CRC if you're going to run locally on a code-ready containers. So you specify what type of cluster, and then whether that cluster exists or not. Basically, if you say cluster exists false, then the iteration 0 scripts automation expects to create that cluster for you, and it's going to expect certain privileges and a little bit of extra configuration, which I'll show. If you've already provisioned the cluster and you just want to install the tools, then you just say cluster exists true. It also, if you've installed the tools previously and you're going to reinstall on top, the script will handle that without, you don't have to do the cleanup. We will clean up for you. So you can just install on top of an existing install. It'll wipe out whatever tools were there before and reinstall them, but you can reuse a cluster that way. So if you are provisioning a cluster, we need a little bit more information. That's why this VLAN file is here. We need the data center and the VLAN IDs for public and private VLAN IDs. So normally when you do create through the UI, it's something that a lot of times you probably skip over, or at least initially I had, that it'll automatically pick a VLAN for you based on the data center you've picked. If one doesn't exist in that data center, it will automatically create one for you. Now, in this case, we expect one already exists. You need to tell us what it is. Now, we do provide some tools to help you out a little bit. So there's in the CLI, let me make this bigger here. So in this IGC CLI, we give a VLAN command. So that will read from, it expects that you've already logged in the IBM Cloud CLI already, which I have here. And I've logged into the US East region with that CLI. So it's going to read in US East all of the data centers in there, and we'll find all of the VLANs for those data centers that exist. Now I can pick which data center do I want to use, and then within that data center, which VLAN do you want to use? Now, typically in this case, I would just take the first one that shows up, but depending on what you're doing, you may have a specific VLAN you want to pick. And so it spits out the format of those variables in the way that need to be pasted into here, right? So if you are provisioning a cluster, that's an easy way to get that information and populate this file. So that said, we're going to use an existing cluster, so we don't need to mess with this. The values in here will be ignored. So the next piece, so any questions so far on that? Anything that's not clear?
Postgres server access is kind of confusing. I think we should delete it.
Yes, yeah, it needs to be removed because it doesn't apply anymore. This is historical. So we install SonarQube. SonarQube depends on Postgres. For initially, we would provision the Postgres service on the cloud and use that instance for SonarQube. But that's a bit of a sledgehammer for what we're doing. So now and also provisioning Postgres service takes a long time, comparatively. It takes like 30 minutes. So when we were testing, provisioning a new Postgres over and over was painful. So that we added that ability you could provision Postgres once and then just reuse that instance over and over. Again, partly it was to make our testing faster, but now we are we're deploying a Postgres pod into the cluster that SonarQube will use. So there's no dependency on external Postgres for the tools. If your application needs Postgres, then you can deploy it, but if otherwise you don't need it, and you shouldn't, because it costs money too, and it's overkill, like, it's a sledgehammer for what we're doing. So we need to remove it because it's not actually, in this case, Postgres, as I show, is not being installed anyway, so that flag doesn't have any meaning. So we should remove it.
I found it confusing, but I wanted to ask.
Yeah. That's a good question.
Okay. Yeah. Another thing is sometimes it's confusing which variables are applicable to CRC or not CRC, or if it exists or it doesn't exist.
Right.
So
Yeah.
I think
So
we can improve it a little bit with comments.
absolutely.
Go ahead.
Well, one of the things along those lines, we're looking to overhaul all of this anyway, to have a CL, the script that you run for Terraform to be more interactive, to set these values, or if you already know what you're doing, you can provide this in YAML and not have to mess with any of this. Because to that point, for CRC, none of this matters. Right? These are all very specific to. So if you say CRC, we assume or we expect the clusters already exist because we're not going to provision it, and none of these other values have any meaning in CRC. So to that point, we can hide some of those details if we're a little smarter about it. So that's one of the things we have planned in the very near future. So,
Sean,
anything else? Mm-hmm.
a comment. Do you have the developer guide where you can show it?
Yes.
I think you're through talking about the configuration files.
Yes.
And here, yeah, if you go to plan installation, so that page and configure account, and
Right.
and then the 3 pages after that are the install pages.
Right. So
Those
here,
walk through explaining. Yeah.
so these link to install new, install existing. Yeah. So this is the walkthrough of one. As you point that out, currently the Terraform scripts don't create the access groups or the resource group. At some point, we'll have a module completely automate all that. But what we do have is a set of scripts to set up to configure the access groups once you create them. And again, those details covered covered well last week. So we're not going to go through that. But those scripts that were mentioned last week they live here in this iteration 0 repository. And that's a step you would do after or concurrent to, I guess, the cluster setup is setting up the access group and providing the access needed.
Right, and those pages explain a lot of the process for coming up with the values that you show in these files.
Yeah,
and knowing which values apply to which kind of install and that sort of thing. It's explained here.
Yeah, so we'll do existing because that's kind of what we're doing. So cloning the repo, setting up the API key, configuring the values, right? So all of that is covered in detail here. There are a number of other scripts we provide here. I'll come back to that in a minute. And particularly these are used a lot of times when things go south or when you're trying to clean up some of these other scripts. The apply is what's actually used when we run Terraform. And then there's the RBAC, which we'll talk about, that install on the cluster some role-based authentication that hooks into the IAM access groups. So now we're configured for our cluster and we're ready to go. So the next piece that we touch on a little bit, but we don't cover in detail on the developer guide, and we need to, is how do you make tool selections for the install and turn things off if you want, or turn things on. So right now it's a fairly simple process. The way we've organized the Terraform is we put each module or each component that's going to be installed in these stages folders. Some of this is a little historical with the naming, because at one point we would take all of the stage 1 things and apply them together, and then go back and take all the stage 2 things and apply them together. We found it's cleaner and more efficient to just apply them all at once, but we still keep the kind of the stage notion so that we logically group them. So so stage one is and recently combined this. We used to have a namespace, but there's not really a point to keeping that apart. So stage one is applying the module for the cluster. So this is assuming an IBM Cloud cluster. It's going to attach to the cluster, and or if you want to create one, it will go off and create it, and then come back and export some of the details about the cluster, the ingress subdomain, the name of the secret that holds the TLS credentials or certificate, the version that was installed, things like that. If you have an existing cluster, then we attach to the existing cluster and read that same information out so that downstream, the downstream modules have the information they need to work. We also provision a set of namespaces as a part of this. It's configurable what you call them and how many you get. By default, right now, you get a tools namespace where all of the tools get installed into. You get an the SRE namespace that is a IBM Observe is what it's called, because that's the name that LogDNA and Sysdig use by default. We've just kept that. So it's a namespace where the monitoring and logging tools get installed. And then you also get a dev, test, and staging namespace created initially. Now we're changing that to, as we kind of evolve, that we won't be provisioning a dev, test, and naming or staging namespace as part of the Terraform. You would just do that afterwards when you first create it. And you can rename the tools namespace. There's a couple of places where we need to make the CLI easier to work with. But you could rename that. That's all. Well, I'll show that in a second. I'll show where you can customize some of those values. But that's the cluster. And then we have everything in stage two is essentially our DevOps tools that get installed. And right now we have a default set. And so the model we've tried to follow is we give a set of defaults that work well together, and we give you options that you can change, interchange, and the modules, the options that we provide should still work well together, but it's kind of an opinionation of or a starting point. But there's no reason going forward, there's no reason why you couldn't pick Nexus over Artifactory. And I just did a demo, so I have some stubbed out ones here. We're fleshing these out. So it's Nexus as an alternative to Artifactory, and then any other modules. This being open source, the idea and the hope would be as different practitioners come to a project that needs a new tool, another alternative to Nexus and Artifactory that does artifact management, that they add a module, and then there'd be another option in the catalog to install. So the way this works, anything that's in the root stages directory is going to get picked up and applied. So if I don't want to install LogDNA and I don't want to install Sysdig, which we highly recommend you install a logging and monitoring framework up front, whether that be in cluster Prometheus and Grafana, or whether it be LogDNA and Sysdig at the cluster level. But part of what we're trying to do is set up, build, to manage from the beginning. A lot of these tools, one of the kind of feedback I've heard from different people is, well, it seems like a lot of tools. I'm having trouble wrapping my head around all of that set. Do I need them all? And the answer is no, you don't. If you don't want to do Swagger or SonarQube, you can remove them, just in the same way I just removed those others. The pipelines that we've built are smart enough to detect if the tool is there, and if it is, it will use it. If it's not, it will skip that stage. So like the SonarQube scan, if SonarQube is not installed, the pipeline will know that, and it just go on to the next stage and not try to do anything. So you can remove it, but most of these tools, well, all these tools in this stage are very low overhead. That most of them, take Jenkins, right? There's a UI that runs, but it's dynamically spinning up agents when you request a build. So it's not using a lot of resources. So there's not a lot of downside or reason not to include these things to start with. Now, if there's a competing tool, like if the customer is using Nexus and would rather use that instead of Artifactory, then you can interchange that. But the kind of the tool chain itself, we'd recommend, unless you have a very clear reason not to, just to install those. Now we also have a set of services, Postgres, Cloud Object Store, that you can add. If your application makes use of those, that you can add and install. But you also don't need to do that up front. That can be done after the fact. So we take the base set of tools. I'll just take these. One of the things I was mentioning is the variables. We have a set of variables. This is one of the things we want to make a little easier, a little more obvious. But these are all the base variables that we have, and they have, some of them have defaults. Some of them, like the private VLAN, is an empty string default, which is why it's not required if you're not provisioning. You don't have to do anything with it. Some of them, like VLAN region, doesn't, so that means it's required to be provided. And then, so then we have default values for some of these, like release namespaces. And this is where I was saying we have tools, IBM Reserve, and 3 namespaces. So ultimately, if we're not, when we remove the defaults, then we'll just leave that empty. You can add them if you want, but more than likely you would just do that another way. And then, so the Postgres server exists. It's defaulted, so we could remove it and it wouldn't have any impact. So these values get overridden by whatever values you provide in the environment when it runs. But some of them we don't expose. So if you, instead of going in here and making the change here, I could make the change at this level. It's a little cleaner. But so that's how you can customize some of this. And then each of these modules has input. That's what, without going into too much detail about how Terraform is working, like I said, we covered that a couple of weeks ago. Each of these modules has, these are input values that get passed into the module. So each module has a set of inputs and a set of outputs potentially. These values could also be overridden at this level. You wanted to change, instead of calling our service account Artifactory, if you wanted to change it, you could. So now that we've got all of the stages and we've set up the stages the way we want, we can run, delete that. We can run the script. Now we've provided a couple of other things. There's the launch shell script that pulls in a CLI tools image that's already pre-configured, pre-installed with Terraform, with the IBM Cloud Terraform provider. It has kube control, or kubectl, OC, CLI, the Helm, and I think that's it. So basically, the way the modules have been written right now, they require a couple of things outside of Terraform. So we provide those in the toolkit. And so this is a ready-made environment that you don't need to do anything else. It has everything needed to run these Terraform scripts. One of the things we're working towards is streamlining all the modules, so that the goal would be eventually the only thing you need is Terraform. And you'd have to have the IBM Cloud Terraform provider, because since we're a third-party provider, it doesn't get automatically downloaded. So the goal is to get to the smallest footprint, so this image can be as small as possible or not even necessary. But the first thing is we'll launch the launch the script, and what that's done is loaded this this path as a volume. So if I look, the scripts, settings, stages, those are all of the folders here. So all my configuration that I just did is done, and it actually also loaded all the properties from credentials properties in its environment variables in this shell. So I can kick this off. I had removed that. Put this back. So I had, since I removed it, actually the shell script is still asking about it. So it's a little more to clean that up. But it has read the settings that were put in environment TFRs. And so just confirming this is what you want to do. We're going to install into this resource group. We're going to use an existing OCP4 cluster. And that cluster is going to be, it should be named this. Right? So it should exist, should have this name. Do you want to do that? And it's, it's saying we're going to, if you have a tools namespace, dev test staging already there, we're going to blow those away and reinstall. So at this point I can kick it off. So what it's going to do, it takes a little bit up front because it's what we have done. And again, we talked about this a little bit before, but we've split the logic here for picking tools from the actual logic to implement. So the module itself is housed in a separate repository. There's a couple of reasons for doing that. The primary one is that we can version it independently. And these modules could be from wherever. They don't have to be from the one we're providing. There is a full set of Terraform modules, and there's a Terraform registry that, or a module registry that Terraform provides, HashiCorp provides, that you could pull from as well. So we have to pull these down. And so it's pulling the specific versions of the tools, of the modules that we're using. And then once it does that, Terraform works in 3 steps. There's a Terraform init, which is actually what's happening now. So it initialized the modules. It saw that for these modules to work, we need to download this content. So it's pulling it down. Next, it will do a plan, which it's doing now. So it checks for any plugins that are used within those modules that may not already exist. So there's a couple provided by HashiCorp that we're using, null and local, that we don't have in the image, so it went to pull those down. And then it gets to work applying, I didn't pick up that change, I did. So this is because I made that change and it was running before I removed it. I'll go fix it. So what's happened, this is a good opportunity to show some troubleshooting. So what's happened, whenever it runs, it puts it in a workspace, and there's a change that has gone in recently, there's a pending pull request, that instead of just putting everything in workspace, it puts it in a folder named after the cluster. So if you're doing multiple clusters, you don't have to clean up the state, because Terraform, you want to keep track of the state so you can reapply changes. So we've created a workspace folder for this run. We've copied all of the stages over, and my variables here, I think, there you go. Just change that. It had copied it before I changed it back. So that was the error. It's expecting for at least one item to be there. So if I run it again, so there's a couple things I could do. I could run Terraform, and I will go ahead and do that because the workspace is set up. That'll save me having to copy everything over again, or pull down the modules again. It'll just pick up where we left off, and it'll be running and applying the changes. So the way Terraform works is it keeps track of state. By default, that's what the stage 0 is. It's saying that we are storing our state in a local file system. You can configure it to store the state elsewhere, like a database. That's particularly useful if you have a bunch of people that will be managing these environments that need to keep up with the state centrally. You can, in the file system, commit these changes back to your repo and just make sure you do a pull before you run again. So that's a easy way to do this as well. So all the state is being stored here. So as it runs, as it applies resources, those get added to the state, and it will, once it's done, it will have reconciled the desired state with the actual state, and it'll say everything's good. So it's functioning similar to the way Kubernetes works, right? You describe your desired state in these stages and in the modules that go underneath them. Terraform compares that desired state with your expected state, or with your current state, and it applies anything that's missing. So that's how, while this is running, you can, if you come back later and you say, I want to actually add logDNA and sysdig. We'll rerun here in a minute when it's done. So this takes about 20 minutes. It's installing the tools. In this case, it was just the tools. So it's creating the namespace, installing tools. It's we've worked out within the modules the dependencies between them. So Terraform will wait until the cluster is ready and the namespace is ready to start installing the tools. But like if it's provisioning a service, it will do that right away and maybe wait until the binding is done. And each tool will wait until the tool is ready. So right now we tell that by checking if the route or ingress is available. So we'll check. If it's not available, we'll sleep for a little while and check again. There's a number of times we'll check before we give up. And so if a tool is just not ready after a certain number of retries, then we'll quit. So that, we had a problem in one of the accounts where there was no persistent our storage. We kind of ran out of storage because we created a bunch of stuff real fast. And so instead of provisioning new storage, we just needed to clean up some stuff. And but in the meantime, we have a couple of components like Artifactory and Packbroker that need persistent volumes. Those failed to provision because there was no persistent volume available. So that's one that it retried several times and then eventually failed. There at one point the scripts would just test forever, so we put a cap on that. If within, I forget what the number of retries and the time is, I think within 30 to 45 minutes, if everything's not ready, then it's probably failed. So one of the things that's happening, one of the novel things that we're doing, I'll go to an existing cluster, is we're actually, with each tool, we install the tool, but we also install a config map. How does it work? A config map for each tool that's been installed. So API editor, Argo CD, Artifactory, and in that config map, we can do other things, but at a minimum, we put the URL of the tool that got installed. We also, for right now, since we're not hooking everything into single sign-on, we also create a secret that contains the credentials for that tool, at least for the admin user. So we use that in the pipelines to know. That's when I said earlier that, hey, if SonarQube is not installed, that the pipeline will just skip that step. The way that works is this one. Oh no, It's in the this is easier viewed here. Let me just show you here. Yeah. So in this is Tecton, this is similar for Jenkins. We are loading that configuration from the config maps. It's optional. So if it's not there, there's no problem. And then we're testing if those values exist. And if they do, then we'll use them. And if not, we'll just skip that step and not do anything. So that's how we're able to plug in tools, is through the configuration, through the config maps. And so some of that we're, to accommodate alternatives, making it a little more generic. So it's not just SonarQube or Artifactory config. It's Helm repo config and quality scan config. Although SonarQube, the logic is a little specific, so something like that we'd probably just have to handle through different tasks at a Tecton level. You could replace them, but that's how the tools can be interchanged or dynamic. So we're installing both the tool and creating a config map secret as a part of that. We also use that information on the dashboard. Go back to the dashboard. So the developer dashboard that we install reads those same config maps to know what tools exist and provide the links to them. So this is just reading the config map and adding and providing a link to it. So that's how we add.
I have a question. How can we add TA here, this landing page, once TA is installed, Flatpak for application?
So that's through the CLI. I don't have, so there's a couple ways to do it, but the CLI is the easiest. It's IDC tool config.
Okay.
TA is the name. Right, so if I do that and I go here and refresh, Transformation Advisor is now available, right? So again, all that the dashboard is doing is reading that configuration. And then, so let me go show you what. So now this is not going to go anywhere because I put a bogus URL, but if you'd have the real URL,
I got it.
Put that in there, right? And we're working to automate that a bit more when you, if you have a ICP for A install, making that a little more seamless. But it also means you can have tools, other tools that aren't part of this environment that you create config for. It also means one of the models we have, say you're at a shop that uses Artifactory, but they have a central enterprise Artifactory instance. They don't, they don't want, especially if you're storing images, you're using it as your image registry or your Helm repository. You may want that in one central place and not have a copy of Artifactory in every cluster. So the easy way to fix that is, well, instead of installing Artifactory, you just install the config map that points to the central instance, because it's just a URL and credentials, and then the pipeline will use those credentials to call out to an Artifactory that lives somewhere else. Same thing with the, like I said, the image registry. You can point that elsewhere, and then the pipeline will use it accordingly.
Okay, thank you.
And so right now, there's one more change that we need to make to the dashboard to make it completely dynamic. Right now, it expects some certain names that it looks for to be able to do the images. Ultimately, we'd like it to be completely reliant on the config maps. So any config map you add will show a tile with an image. Now you have to either provide a link to an image that lives somewhere, or you can base64 encode it into the config map, and then we'd be wide open for any tools that you want to add to the dashboard and into the pipeline. One other thing I was going to say about that. Oh, any other questions on that so far? So again, that config map is part of what makes this so dynamic. I don't know if you've used the CLI to deploy a pipeline, but that's how we're able to, like when you clone a repository and do IGC pipeline, you don't have to provide any configuration about the environment you're deploying into or about the repository, because we get all that information either from configuration that's already available in the cluster or configuration that we create as a part of the IGC pipeline command. So we're taking advantage of what's available in Kubernetes in terms of config maps and secrets to kind of make this pluggable. And then we're also doing some work to integrate the dashboard a bit more into the console. On this one, all right, so we've got a link to the dashboard here. The idea is to be able to link to some of the other tools in the same way, so it's a little more integrated in with the developer experience. So some of that would be provisioned as a part of the Terraform. So this ran, it completed successfully. I don't know what the total time was, but you can see with each of these, okay, Artifactory is there. I can click that link and I can see, okay, here's the Artifactory instance that was just provisioned. Now with Artifactory and Argo, there's a little bit of extra manual steps for right now. We're looking to try to automate that, but you get a base install of Artifactory. And I mentioned the config maps and secrets, since we don't have full single sign-on. So we have a CLI. Let me log into the right cluster here. We have a CLI that'll help get you the credentials, a CLI command. It's just reading those secrets that are in the cluster. So if I do IGC credentials, it gives me, so for this Artifactory instance in this cluster, it starts with a password of admin and password. One of the first things you have to do when you log in is to change it, and that's part of the setup that has to be done. So if I go through the setup, I create a new password. I'll just make one up for now. But now, part of the setup too is to go back to the secret and update the password that I just created. If I typed it correctly. So reset the password. You have to set the base URL, which is basically just this URL without the slash on it. Skip that step. And then what repositories do we want to create? So I've been just creating all of these. But so one of the things, because we're using the open source version of Artifactory, it's limited in some of the repository types that you can create. So we've been using the generic repository as a Helm repo. So there's others that if you have a license for Artifactory, you get access to. So using it as a Helm repo, you know, the full integrated Helm npm Docker registry. But I'll pick those for now, and it'll create those for me. There's two other things we have to do just to finish the setup. One is from a security standpoint, allow anonymous access to so that our Helm repo doesn't require authentication to read from. You could leave that off and then require authentication to access the Helm repo, but for our purposes, it's easier to do that. And then one last thing is we need to get the encrypt password. So I have to put in my password and get this encrypt password here. So to use the API with Artifactory, you can't use the password. You have to have this encrypted password. So with that, I need to go back and with that, I can go into the cluster and into the tools namespace. And I need to update my Artifactory access password. I do this. So in 4.3, you can edit the values directly without having to, it'll base 64 encode them for you. In 3.11, you have to do that yourself. So my Artifactory password, I changed it to the very complex my password. And my encrypt password, I'll paste in. There you go. So now Artifactory is available to be used in the pipelines. It won't work until that encrypt password is there. So now Artifactory is available for use. One other thing that we have to configure is if we want to use Argo for our continuous delivery, is we need to tell Argo, the way Argo works, if you're going to use a Helm repository, you have to have told Argo about it in advance. It's a trust thing where you can't just pull Helm from wherever. You have to have told it, you know, this is a Helm repository that we're going to be using. So we have to get the URL for our Helm repository. And then previously downloaded or cloned the Git repo, so I have it locally, but we add a script to make it easier. So if you go into config, there's a script to add the Helm repository for Argo. Essentially, it's getting stored into a config map for Argo. But if I do add Helm repository and put in my, also need the namespace, which is based after the resource group name. So if I add that as my Helm repository, now Argo, that's the last bit of configuration for Argo. Now Argo is available to be used in the deployments. So we're set up. Our environment is now ready to be used. We have an example that we were using this morning. Sure I'm in the right environment. So where we have a pipeline, these are Tecton pipelines that are pushing into just doing the health check and packaging, pushing into the Artifactory instance. So I can look here, artifacts. Right, you can see the artifacts that were built, and these can be deployed. And we are using Argo that's here to deploy those into the dev and into the test and staging environment. So any questions about that? I'm getting close to the time, but. So a couple more things quickly as we're getting to the end. What to do if things don't go well. So you have this workspace directory. Depending on the type of error, you can just rerun it if you make a change to the environment. Sometimes there's a network hiccup in the middle of doing something with the cloud, or the cloud has an issue. You can just rerun it, and then it should pick up where you left off. So if I run Terraform plan on this now, it should tell me, after it thinks through it, that everything is already installed. So at this point, if I want to remove anything, I can do like anything individually. You can use Terraform destroy to remove a particular resource. So there's a trigger here that's making this change. But if I wanted to, so all of these resources here, if I wanted to delete, find a good one. I want to delete SonarQube. It's a matter of I want to delete the SonarQube thing. Target. So if I want to just destroy a particular component, remove it from the system, I can do this. And then if I did an apply again, it would put it back. If I copied logDNA and sysdig over, those would be applied. So you can do continue to add from the environment, and so incrementally add new components as you come to them, right? The just enough architecture approach of, okay, I'm starting my project. It's a very basic project, so we don't need anything, but a couple weeks in, we realize, hey, we're going to use a Cloudant database, or maybe we've deferred that decision until we have more information. We want Cloudant database, so let me add Cloudant. Get a little further along, it's okay, we need to do some caching, so let me add Redis. So that can be incrementally added to the environment as we go. So that destroyed SonarQube. It also destroyed the Postgres. So all of the resources that were created as a part of SonarQube from that cluster. If everything goes sideways, if you just want to start over, the easiest way to do that is just to delete the workspace directory and then rerun. The one caveat there is right now, if you provision services, you'll either need to remove them so they don't get provisioned again, or from the folder, or delete them. So that's one of the scripts that we have, is destroy services. It'll look for anything with that prefix. So I didn't just install any, so it didn't find any, but you can go remove the services and do a clean restart. On 3.11, there's an issue where something, it depends on what you've installed there. Some components are causing problems. If they put a finalizer on all the namespaces, and 3.11 does not support that. So you may get into a state where your namespaces can't be deleted. This kill kube should take care of them in most cases. It essentially removes the finalizer first. So if you're running the scripts and the namespace won't go away, that's one way to do it. You can destroy the cluster from here. And then, as I mentioned, the RBAC sets up the groups. So any questions on that? one last thing, I guess, is that if you're installing on CRC, we have a cut down version of the components. Number one, because it's not IBM Cloud, so you aren't going to provision services. And number two, because it's reduced resources, there's some reduced requests, or reduced like the persistent volumes are smaller or removed altogether. All right, any so again, this is a place to go for, so that Artifactory setup that I did is documented here. Argo setup is here. And then more detail on how the modules are constructed and some of the customization that can be done is here. All right, so if there's no more questions, then I think we can wrap it up.
You went over the Argo setup and the Helm URL. One thing that is tricky is the Helm URL at the end. At least in Tecton, it adds the namespace. So if you have 5 namespaces, you need to go to Argo and use that script of adding the Helm, and the Helm URL is actually have the namespace at the end. You have to add it like 3 times if you don't want to type it in.
Yeah, I did that. Well, you still, there's no way in the UI to add it, to configure that.
Yeah, through the CLI. I did it through the CLI.
Yeah, you have to do it through the CLI or through that script that we have.
Or when you create the app, I did it when you create the app, just copy paste the URL,
so
but it needs to be the URL where the index.yaml is located. Some people get confused.
That's one thing that's different between Tecton and Jenkins that we need to reconcile. I think the way the way Tecton is working is it's based on the namespace you're running in is your Helm repository. Jenkins, it's always based off of the resource group, or there's a high level registry namespace you set that's not dependent on the namespace you're running in. So in either case, as you're saying, the URL that you need to register is the one that has the index.yaml at that level, because this URL is your Helm repository. So that means in this case, we have multiple Helm repositories. And like you said, you'd have to register those separately.
But in Jenkins, what do you do with when you have CRC and you don't have a resource group, or
there's
push into the internal registry?
In CRC, there is a, so we didn't talk, so this folder for CRC, like I was saying, it has some presets that are specific to CRC. So like the server URL, sorry for the scroll, but maybe that's in here. It's at a lower level. But we set like the, so it gets defaulted inside to something generic like CRC, or one of the things that needs to be exposed more, but it gets a value that is used across all of these.
When I deployed, double check.
Okay.
It's empty. So that's why I didn't have a folder.
Yeah.
It's not defined. I use the namespace. That's the best fallback, right?
It should probably be defaulted here for CRC, right?
And resource group name, it's an IBM Cloud terminology. I don't know why we're relating that to a Helm
generalized
artifact.
Well, it's more
it could have the same values, but if somebody already has a Helm repo with 20 charts and they just want to hook this and plug in these new charts, where do they put that Helm location?
Yeah, so that's some of the names need to be generalized so that they make sense across environments, because the install on OpenShift on AWS, for example, would be more like a CRC install than the other, right? So making these values such that they make sense in that environment. Part of the approach or mentality is, to make the modules interchangeable, we want as much as possible for the variables to be the same so that, you can swap one in for the other. But that means, like for the cluster, we need to make, and for some of these things like resource group name and region and IBM Cloud API key, we need to make those names more generic so they make sense. So you can use the same variable and just swap them in and out, but the value will be different. Obviously, if you're on IBM Cloud, it's the API key. If you're on.
Yeah, we can clean that up. But for Helm specifically, I feel that the pipeline should use a config map that has the location. Like, there should be a config map with something Helm, and that thing should have
have the full Helm URL
and the full, where do you want to put it?
Yes, absolutely.
Pipelines in that namespace are going to put it there, or cross namespaces. It could be the same value, but it should be driven through a Helm config map, not something about.
And yeah, that also, as we start, adding other tools like Nexus or whatever, then it would just be, whatever URL is appropriate for Nexus, that's the value that would be in there. And then, because that's a nice thing with Helm, is there's a good standard for how you publish to a Helm repository. We're having to do a little bit extra for Argo or Artifactory because, we don't have we're using the free version, but we can make it generic. So, hey, if you're in an environment where you have to manage your own index, then, you run these steps. And if you're in an environment that manages the index for you, like Nexus with its Helm plugin, then you don't have to do that. But having those URLs like that for Helm repo URL and Helm repo credentials, instead of calling it Artifactory, makes sense. Now we'd still have a config map for Artifactory so that the tile shows up properly, but it'd be at a different level, right? The URL would be to the specific Helm repo.
Yeah. That's just minor catches that I was doing Tecton. I always do Tecton. I never do Jenkins, and we keep saying Tecton and Jenkins are the same. And then I read the documentation, and it doesn't work because it's missing that folder, and I cannot find the value.
Yeah, we need. Yeah,
so that's like you say that it works for you, and you read in Jenkins, and you say it doesn't work for me.
Yeah, keeping those two in better sync is one of the things we need to work on. Part of the problem is they're in two separate repos. Bringing that together in some way is probably
about putting in a garage pipeline. Yep. Okay. Good. It's good.
I've got some drift there, but yeah. So yeah, we did that. I did it kind of quickly, and I mean, it's good to point out the fact that there may be multiple in there, and each needs to be registered.
I have one last question, Chen. I think it's late, but anyway, I have to ask that one. I see a failure whenever I install related to Cloudant. So you time out, and then you get the message, of course, expecting ready to go or something like that. I don't remember the right.
So when was the last time?
Provisioning.
Yeah, so that was a problem in the IBM Cloud Terraform. Somewhere got out of sync. So we have a newer version of the provider now, and that should be resolved.
Okay, so in case of failure, I go to the Terraform state. I will not see that tainted anymore.
So you shouldn't see the failure anymore for that specific one. Now, it's still possible, like I said, that at times if your network has a hiccup in the middle, so you might have a failure, you should be able to just rerun it and it will pick up.
That's where the problem is. I'm fine with the failure. So you let it fail, you wait a couple of minutes, sometimes you don't have to wait, and then you see that Cloudant is ready. You You run it again, you think it will go through. When it starts, it deletes it immediately. Then you're looping. So I did that 10 times. I say, wait a minute, stop. I went to the Terraform state and I have seen the status was tainted. Tainted meaning delete it immediately. So you keep looping, looping, looping. And when I delete that line tainted, run it again, it went through finally.
Okay.
The state. One thing that we did to avoid that problem is probably the people are getting started, they don't need App ID and Cloudant, so we remove.
Those are okay. Only Cloudant is causing that issue. Only Cloudant is having that tainted thing, which tell Terraform, don't check whether or not it's ready or not, just go ahead and delete it. You delete it, and then we recreate it, 20 minutes, the same issue. So you keep looping, looping, looping.
Yeah, I'll write that down and look, because I think one of the ways to fix that is the way the triggers are configured in on the Cloudant module, so that it triggers appropriately. It knows, it knows, hey, the state has changed, I need to do something different, or maybe it's not.
Okay.
I'll look at that on Cloudant for the way the triggers are set up. Like I said, that specific problem has been addressed by upgrading the Terraform provider, and that's part of the value of having the CLI tools image as well, as we're keeping that up to date. You know, as there's a new version of the Terraform provider, we install it. The new version of the you know, different CLI tools will upgrade it. Especially since, you know, like I said, it's unfortunate the IBM Cloud Terraform provider will not automatically install. So we have to automatically, you know, we have to manually upgrade it in the tools image. But like I said, that should have fixed that specific problem. But I think there's still an underlying issue there. You're talking about with the looping. That I'll get an issue written up and we can look at it.
Yeah, I sent you a note already. Anyway, thank you. I appreciate it.
And like Carlos said, we've kind of reduced the default footprint so that those application level tools really started thinking about it in 3 levels, right? There's the cluster, and I really need to put a label on there, but there's the cluster, how it gets there. We will provide it for you if it's IBM Cloud, but otherwise you get it there somehow. If you've got your own Terraform scripts, if you've got Ansible, whatever, get the cluster there. Then we install those DevOps SRE tools on top. And then there's application services and in-cluster software that are needed for the application, right? So we made the change so that we don't have any external dependencies for the tools. They will install. You don't have to provision any services or anything like App ID or Cloudant. But if your application has need for those, then you could add them and provision them. And that's where the kind of the progressive addition, as you learn things about your app and you need new tools, you can add them. All right, so we're over time. Any other questions?
I think that's a good wrap.
All right.
Thank you.
Well, thank you. Have a good afternoon.